Many people picture planets in the universe as either as habitable as the Earth, or at the very worst, as scorching as Venus. Truth be told, most planets are hostile environments where life has no chance of surviving. These planets are some of the most dangerous and inhabitable ones in the cosmos. But before we dive into these menacing exoplanets, hello there, and welcome back to the Discover Space channel, where we explore the cosmos, the good, the bad, and all in between. Be sure to subscribe if you haven't already, and let's get on to the video. The word planet originally meant wanderer in Greek, and many prehistoric cultures were aware of these moving objects. But astronomers couldn't examine them in greater depth until the invention of telescope in the 1600s. But what defines a planet as a planet? A planet must meet a few requirements, including the ones listed below. It must orbit a star or the sun. It must have a mass for its self-gravity to outweigh rigid body forces, assuming a hydrostatic equilibrium shape that is almost spherical, and it must have cleared the area around its orbit. The term exoplanet refers to planets that are outside of our solar system, and according to scientists, there are billions of these dispersed throughout the massive universe. These exoplanets are among the worst and inhabitable in the cosmos. The first exoplanet is the Kelt 9b. This planet is incredibly strange in every way. It is actually one of the strangest and hottest planets ever discovered. The hydrogen gas molecules are probably torn apart on the day side of tidally locked Kelt 9b, being unable to reform until their detached atoms travel around to the planet's night side. Because the heat of Kelt 9b is so intense that even molecules can't remain stable. Kelt 9b is hotter than most stars, with dayside temperatures of about 4,300 degrees Celsius. But because of how hot Kelt 9b is, the planet is probably being destroyed by evaporation. Although it is 2.8 times as big as Jupiter, Kelt 9b is barely half as dense. Scientists assume that the planet's atmosphere has ballooned due to the intense radiation from its host star. The planet's odd orbit, perpendicular to the star's spin axis, is another peculiarity. That would be comparable to a planet revolving perpendicular to the solar system's plane. 1 year on this planet is less than 2 days long due to its close proximity to its sun. In terms of the age of the stars, the Kelt 9 star is quite young at 300 million years old. Both its size and heat are approximately 2 times that of our sun. The planet may possibly be exuding a tail of melted planetary material like a comet, due to the intense ultraviolet radiation that is continually bombarding its atmosphere. You can find Kelt 9b 670 light-years distant, near the bright star Cedar at the core of the Northern Cross in the constellation Cygnus, the Swan. When it is dark, you may clearly see it in the northern hemisphere summer evening skies, high in the eastern sky. How do you feel about exploring an exoplanet with lava flowing everywhere? The K2-14-1b is an exoplanet the size of Earth with an ocean of magma, a rock vapor environment, and winds reaching supersonic speeds. K2-14-1b is one of the 2 planets in the star system that is 202 light-years from our solar system, and points in the general direction of the constellation Aquarius, the water bearer, which may be seen on November evenings. Naturally, planets that are orbiting their stars nearby tend to be more hotter than planets that are farther away, like Mercury and Venus in our own solar system. However, There are planets in other solar systems that orbit their sun even more closely than Mercury does. K2-14-1b, a world of contrast that is scorching hot on one side and freezing on the other. Some of these extreme worlds are known as lava planets because researchers believe that magma oceans are molten on at least some of their surfaces. A magma ocean that is about 100 kilometers deep, rain made of rocks that evaporates and afterwards precipitates in a normal cycle comparable to the water cycle on Earth, and supersonic winds of over 5,000 kilometers per hour. This planet, whose radius is roughly 1.5 times that of the Earth, was very recently identified in 2018. The rock that makes up its surface, atmosphere, and ocean is primarily sodium, silicon monoxide, and silicon dioxide. Another unique characteristic of this planet is that it is tidally locked to its star, which means that one side of the planet is always facing the star, exactly like the moon does. By examining the planet's illumination patterns in the telescopic data, the astronomers came to this conclusion. The fact that K2-14-1b is tidally locked causes significant temperature fluctuations between the day and night sides. It is extremely frigid on the side that faces away from the star, with an estimated temperature of less than -200 degrees Celsius. However, the estimated temperature on the side that faces the star is a blistering 3,000 degrees Celsius. We consider Venus's hot surface temperature to be hot enough to dissolve rocks in our solar system. Rocks on K2-14-1b, however, can vaporize because to the extreme heat. The rock that has been melted has contributed to the planet's thin atmosphere. Precipitation is also produced by the rock vapor formed on the day side of the planet. Although there is no water present, the cycle is essentially the same as what occurs on Earth. Because the supersonic winds deliver the mineral vapor to the planet's night side, where it rains down to the surface, it behaves like rain on Earth. The precipitated materials are carried by the magma ocean's currents back to the planet's hot side, where they re-evaporate. Although the cycle is regular, it is not as steady as on Earth. Since the magma ocean is moving slowly back toward the hot side, scientists believe that the mineral makeup will gradually alter over time, influencing K2-14-1b's atmosphere and its surface. This list's final planet is a diamond world. Discovered in 2011, PSR J1719-1438b is a gas giant exoplanet that orbits a pulsar. A pulsar is a neutron star that is extremely small yet extraordinarily massive. Despite having at least 1.4 times the mass of our Sun, pulsars are typically only 20 kilometers or 12 miles across. This neutron star spins so quickly that it doesn't seem to be moving at all. It can rotate at 167 revolutions per second. Despite being only 40% of Jupiter's size, the planet PSR J1719-1438b has a mass that is almost identical to that of the gas giant. How is it so tiny and yet so massive? The planet, according to scientists, is the remains of a star whose outer layers were sucked away by the more powerful pulsar. The pulsar stripped away the planet's outer layers, but they left behind a residue made mainly of carbon. In other words, this exoplanet is basically a diamond. And it's a diamond that is about 5 times bigger than the Earth. Additionally, this indicates that this planet is bigger than its sun. Our diamond planet, with a diameter of around 60,000 kilometers, is 3,000 times bigger than the pulsar it orbits. Additionally, the planet and pulsar are so near in proximity that the complete system might fit inside the diameter of our Sun. This planet is so near to the star that if it were much larger, the pulsar's gravity would demolish it. And that is it for this video. What do you think about these menacing exoplanets? Is it something to be scared of? Is it more of a possibility? Let us know in the comments section below. And also let us know what other adventures you want to take on next, and we shall see you then.